So the project we're going to focus on today is GreenFly. And again, we're going to give a little more background before we get into that one as to why it's important and how the idea came about. So you all probably know that air travel really is emissions intensive. For many of us, it's the biggest part of our carbon footprint. So we're going to, for a moment, consider Kate. This is a persona we've made up, but there are people like this out there. She does everything right. She checks every box for her sustainable lifestyle. She doesn't have a car, uses public transportation, energy efficient home that she shares. Maybe she lives in a co-op, she's a vegetarian. She does all these things. She probably recycles and all the good things. But, and her carbon footprint as a result is much less than the rest of us average North Americans. But she also flies across the country a couple times a year, maybe to visit family, and she goes to Hawaii for vacation every year. And just with that, her carbon footprint is about equivalent to the average North Americans. So you can do everything right, but flying really is a big chunk of our individual carbon footprint. And another problem is that we don't really know this when we go to buy a flight. I mean, and most of you probably are aware of the emissions of flying, and lots of us are, but we're not reminded of it when we go to make a purchase. So this is the interface you see on Google Flights. When you go to get your flight, there's nothing on here about carbon emissions. I'm not picking on Google. It's the same thing if you go to Priceline or Expedia or Kayak or any of the airlines. They don't give you emissions information. So it's very hard to be prompted to think about it and consider it in your decision making. So what are the solutions? Well, I know the focus of the seminar series is on individual behavior, but just as context and to think about some of the broader solutions, there are sustainable jet fuels being developed. A lot of research is going on biofuels. That's going to be a really big deal. There's also carbon taxes that could be just integrated into the purchase price of your ticket. That's another strategy. It's more on the policy side. In terms of what we can do as individuals, we can voluntarily buy carbon offsets. We can just not fly. That's been pretty easy for a lot of us the past year. We can fly less. Or in the focus of the GreenFly project is this idea of choosing lower emissions flights. So I do want to talk a little bit about buying carbon offsets because choosing lower emissions flights isn't something that's easy to do because you can't see the emissions of the flights that you're buying. That's kind of why we have this new project, but you can very readily buy carbon offsets if that's something that you want to do. So I want to make sure everyone knows that that opportunity is out there. You can buy them from companies like the Sustainable Travel International, where I got this infographic. And that allows you to kind of offset the emissions that were associated with your air travel. And that's per person emissions. So you're sharing the emissions of the flight with everyone else on it. You're not taking responsibility for all the emissions. But then there's TerraPass is another website where you can go and buy carbon offsets. This is what their website looks like. You put in how long your flight was, and it makes a recommendation as to how much you should buy in carbon offsets. Now, if you don't know how long your flight was in terms of distance, then you have to look that up. And of course, this is a separate website and payment process than your flight purchase that you got on Google or Delta Airlines or wherever you bought your flight. So you have to go and do that. Some research has been done on buying carbon offsets and consumers' willingness to purchase carbon offsets. I should also note that carbon offsets tend to be priced at around $10 to $25 per metric ton of CO2. So in research on willingness to pay for offsets or a carbon tax, most people are willing to pay for a carbon tax if you put it into the ticket price. And most in this research were willing to pay about the going rate of carbon offsets, about $25 per ton. But when you ask them if they would do this voluntarily, a much smaller number of people said that they would. So convenience is a really important factor. If you have to go make an effort and go somewhere else to get it done and put in your credit card information again to get it done, that's not going to be as effective. So here we get to the solution that we're really focused on with GreenFly, which is choosing lower emissions flights. So it's not well known because you don't get to see the emissions information on flight alternatives when you buy a flight, that the emissions for different flight choices that you may have for the same trip, same origin, same destination, can vary by a factor of 2 or even more. And that's because, well, one of the main factors is layovers. A lot of the fuel used and the emissions generated from flights occur at takeoff and landing. So if you have layovers, you have more takeoffs and landings. But the route also matters, the aircraft type and size matters, occupancy, as well as fuel type matters. So in other words, you could reduce your air travel carbon footprint by up to 50%. You could half it, or maybe even reduce it more just by simply choosing the most efficient flight. But again, that's only if you know what the emissions are. So that's where GreenFly came in. We thought, okay, well, we need to make a flight search interface that prioritizes emissions information, makes it salient, so it can be added to the equation when people are making decisions about which flight to purchase. So this is our website, GreenFly, and it's much like any of the others in that you put in where you're going to go and when. And then there's several features in the output about emissions. So it sorts the flights from lowest emissions to highest. There's also a label. They're labeled Your GreenFly. The flights with the lowest emissions have this badge, Your GreenFly. The bar at the top is showing the range of emissions for the flight options for your trip, lowest to highest and average in the middle. And so it's just showing the interactions of the website and how you can default sort by emissions. You could also opt to sort by price. And again, the highlighting using a couple different strategies to highlight the lowest emissions flight, a green, Your GreenFly label, green text, and a bar at the top that shows the minimum value of emissions. And then a little bit about the website. We used the Google Flights API to pull information on the different flight itineraries and alternatives based on destinations and dates. We took that, triangulated with some other data sources to get information on routes and on aircraft types. We built our own flight carbon calculator that information went into to determine the emissions values for each flight. And then of course, because we're a university and not a business, we weren't involved with payment transactions. So we could just the best we could do would be to link to airlines so that a user could go to the airline's website and purchase the flight. Unfortunately, Google Flights made their API, well, it's no longer free. So our website doesn't function anymore. There's a demo up, but we unfortunately can't use their API anymore, which our site was built around. So maybe one day they'll open that back up. But we can still do research. And that was the whole point, was to demonstrate this idea, try to encourage others to do this and to do research to determine whether or not it's effective. So I want to share now with you our research on this topic. And the main question being, does making emissions information available and prominent in the flight search interface nudge consumers toward purchasing greener flights? We've done 2 experiments. So now I'm going to go over each of those in turn. With the first one, we're wondering, just on the most basic level, how much are people willing to pay for lower emissions flights if they see that information? And then also recognizing that nonstops are already more desirable and their lower emissions, we want to know in particular and pinpoint how much more are people willing to pay for a nonstop, because they're already going to be more willing to pay for a nonstop without emissions information, but how much more are they willing to pay for it when they also see that it's the lower emissions option. What we did was what's called a discrete choice experiment, where you present different options to people that vary in terms of attributes of interest, and you have them make a selection, and it's usually having to do with consumer behavior. So we asked people to imagine their last flight and pick which alternative they would choose from a selection that varied in terms of cost, the amount of carbon emissions, and whether it was a nonstop or a layover flight. And you could see an example question here and how it kind of mimics the GreenFly interface with the greenest flight badge on the option with the lowest emissions, which also happens to be a nonstop one in this particular question. For this experiment, we used Amazon Mechanical Turk to recruit participants. So this is a crowdsourcing work platform. You can go on as what's called a requester or a worker. You can go on as a requester and put tasks out into the world and offer money for people to complete them. So for researchers, it's a quick way to get a lot of data. And for workers, you can go on and get paid to do different and interesting and very diverse tasks. So our participants were all adults living in the US. We made sure that they all had experience flying and also purchasing their own plane tickets, so they'd be familiar with that process. And we had just over 1,000 respondents. For our analysis, what we did was calculate a willingness to pay metric, which is common with this kind of analysis and methodology of the discrete choice experiment. And we calculated that willingness to pay for each of 3 different scenarios. The first being, how much more will people pay for a lower carbon option if we show them only layover flights or only nonstop flights? So in other words, we're trying to keep that variable constant. So if we only change the cost and the carbon, how much more are people willing to pay just to have the lower carbon? Then we wanted to know and these last 2 are related, what are they willing to pay for a nonstop flight versus a layover if we keep carbon constant? So sort of pretending it's not there, like is the naturalistic case in any of these flight search interfaces where you don't see carbon. We had it there, it was just the same for all the options. So it didn't vary. So it wasn't a factor in people's decisions. So we just wanted to see just the baseline, how much more people pay for a nonstop versus a layover. And then we'll compare that with how much more, number 3, how much more will people pay for a nonstop flight when they see that it also has lower carbon compared to a layover flight. And then the analysis was conducted in R statistical software for statisticians out there. It was conditional logistic regression model, which assumes a linear function, and it comes up with an equation with values for each of these attributes: carbon, carbon, layovers, and that's it. So our results for this experiment, for the first scenario, we found a willingness to pay for lower carbon flights at a rate of $192 per metric ton. And so this is, again, not considering whether it's a layover or a nonstop flight. So remember the price that we looked at for offsets. On the high end, you would typically pay at most $25 a metric ton for carbon offsets. Compare that to what we found. By integrating this kind of information into the flight search website, people were willing to pay at a much higher rate for lower carbon flights. Now, that doesn't mean that they'll pay $192 more for the ticket for their flight, because the flight alternatives don't vary as much as a metric ton. So putting it another way, according to our model, these 2 flights would be equally desirable to the participants in this study. If you presented these people with these 2 options, either a $438 nonstop flight that had 381 kilograms of carbon emissions, or a $420 nonstop flight that had 475, that would be kind of a toss-up. people would be kind of equally inclined to pick either of those. And then it comes to our second and third scenarios where we're trying to kind of see do that comparison of what people would pay for a nonstop flight without carbon information versus with. On the left here, so without carbon information, and again, what that looked like was just we gave them options that all had the same amount of carbon. But holding that constant, they were willing to pay on average $51 more for a nonstop flight compared to a one layover, or for a one layover compared to a two layover. So I'll give you $51 more to avoid that layover because it's a hassle. But on the right, when we did vary the level, the carbon information, which is more realistic because the nonstop flights will be less emissions, people were willing to pay $83 to avoid that layover when they also saw that it was the greenest. And that amount got even higher the bigger the difference was in the emissions between the options. So moving on to experiment 2, what we wanted to know was would the results be similar with another population? So we had used Amazon Mechanical Turk. We wanted to test it out with a different group of people. And then we also had this idea about looking at multi-airport regions, or just the airport selection as another variable. So as much as 40% of flights originate from an area that has multiple airports. So people have options of which airport they could potentially use. So we wanted to know, can emissions information sway travelers to use a less preferred airport in the region, maybe one that's slightly less convenient to get to or a little further away, but maybe offers more nonstop flights. So this time we did our study right at home with UC Davis faculty, staff, postdocs, and graduates, anyone at the campus who may travel for work, because we used the business travel context. So we had 477 participants. We asked them to imagine they were going to have a business trip in either Washington, DC or London. Well, we asked everybody about both of those. They got scenarios for each, the domestic trip and the international trip. And for each of those destinations, we had a series of questions where they picked from a selection of flights, very much like experiment 1. And also like experiment 1, the flight options varied in terms of cost, carbon, nonstop versus layover. But in this case, we also added an airport. So for our region, so Davis, California is very close to Sacramento. So SMF Airport in Sacramento is the closest for most of us. But there's also SFO in San Francisco. San Francisco International Airport offers a lot more nonstop flights, and it's about an hour from Davis with no traffic, which is rare. So it is reasonable, and we do often pick one or the other. And what we found was, overall, our model yielded a willingness to pay of $184 per ton. So the UC Davis faculty and staff were willing to pay more for lower carbon flights on average across all scenarios at a rate of $104 per ton of CO2 spare. And again, we have to compare that to that $25 per ton for offsets. And it's very consistent with what we found in experiment 1, $192 per ton that was with the Mechanical Turk sample. So that was good for us to see that 2 very different samples. The UC Davis experiment was very much the business travel use case, whereas MTurk, we asked them to imagine their last trip, which may have been business or pleasure trip. So it was pretty consistent. And then we found something interesting in terms of the preferred and non-preferred airports. So our model predicted that travelers would pay about the same to either avoid a layover or to fly from their preferred airport. So if you had one flight, like for me, my preferred airport would be SMF in SAC. It's a lot easier to get to. If I had a layover flight for $383 out of SAC versus a nonstop out of SFO for $375, that would be a big toss-up because because they're kind of equally valuable to me. But once you add in the carbon emissions information, it can tip the balance in favor of the greener flight. It adds kind of a second pro. So there's now 2 pros and 1 con to that flight. I have to get to SFO, but I have a nonstop flight that I wanted anyways. And now I feel better about choosing that because I also am choosing the greener option. So I get there. And by the way, we did take into account ground travel, emissions from ground travel. And it's still, even if you drive a little bit further to an airport, for a nonstop flight, you're going to be saving more carbon than going to the close airport for a flight with layovers. And then we also did a study looking at all the data from UC air travel that's registered through the accounting department at UC Davis. And I won't go into the details of the methodology, but it's a very involved study to try to model what would happen if we used a GreenFly-like interface for the UC Davis travel portal that about half of staff and students use when they travel. You can go into this website called Aggie Travel because our mascot's Aggie, which is a horse. So lots of people don't use it and they just go on Google Flights or whatever they want to use. But those who do use it, if we could get a GreenFly-like interface onto that site, and our model was predictive of how that would influence people's behavior, we were able to extrapolate and estimate that the university would reduce the carbon footprint of employee air travel by about 4%, which didn't seem really compelling to us. We were hoping it would be more. It's still something. And the University of California has a goal of being carbon neutral by 2025 and doesn't include air travel, but they're getting to the point where they're also going to be setting goals for what's called scope 3 emissions. Air travel falls into scope 3 emissions, which are kind of like things that don't happen directly on campus that are associated with it. So it's still something and it's still a big deal. But then what was compelling was that reduction in carbon was associated with $56,000 in savings, because what our model showed was that people would end up choosing nonstop flights that were available in SFO that are actually cheaper than layover flights that are available in Sacramento. So this is very context dependent. It might not be the case for all multi-airport regions. I don't know. I'm sure you guys probably are in a multi-airport region in Massachusetts. And so I'm not sure because it could potentially work the other direction, and an institution that implements something like this might be spending more. Of course, they could frame that as an investment in carbon reductions. And this was why we looked at the impact on costs too, because we were afraid the university wouldn't want to implement something or would be hesitant and would really need to take into consideration what the financial impact would be of encouraging everyone to take potentially more expensive flights, because we do think of nonstops as sometimes being more expensive. So in conclusion, what we believe is that this is a really important strategy and it's not being utilized. Having emissions information during flight search could really nudge consumers towards picking flights that are lower emissions, and they would do that, it seems, very readily from our data. And so this strategy could be adopted by airlines and their travel booking websites, flight search engine companies like Google Flights, Expedia, Priceline, Kayak, all the rest, very easily. And institutions like the University of California and other large institutions that have private vendors supplying an employee travel booking service. For example, ours that I mentioned, Aggie Travel, does have emissions information in it, but you have to open up each flight alternative, you have to expand it, and then you could see, so you could expand one flight option, write down the carbon, expand another, write down the carbon, and then compare them. But it's not like our GreenFly interface that really prioritizes and tries to make that information salient and persuasive. But the university could insist that they reorganize it And Google Flights and the rest are more than well enough equipped to do something like this, and they could create a carbon. So we created our own flight carbon calculator, but they could very easily create one. So we really want to get the word out on this strategy so that it can be adopted by these companies. Still, though, it's only part of the solution. It's not everything. We think it could be combined with other approaches, such as encouraging fewer flights. That's still important. Even if you take the lowest emissions flight, it's still going to be a large portion of your carbon footprint, because flying just is a lot. There's no way around that. Also, there needs to be more educational and contextual information about emissions. So even though it had quite an effect on people, we did hear from people in our studies that they didn't really understand in a concrete way what a certain amount of carbon meant, and that would have been meaningful. Interestingly, in our first experiment, we presented carbon emissions information in kilograms, and in the second one, we did in pounds, and we still found very similar results. So in the pounds, that was because we thought it would be more meaningful to Americans, because pounds, we're not on the metric system. Pounds kind of resonate more with us. We know what that is. And also pounds are smaller size units, so the number is bigger. And we thought that would be more impactful to have larger numbers of emissions. It looks like more, feels like more. And one very clever person pointed out that, in fact, if you put that money, instead of buying the lower emissions flight for more, if you put that much money towards offsets, because offsets are so much cheaper when you look at those rates, you could buy way more offsets. You could offset 10 people's flights if you're willing to pay as much on offsets as you are for the greener flight. But it's just that trick. It's really about choice architecture as a behavioral economics concept. It's a trick of presenting the information in such a way that people are willing to do it. They're willing to get the greener flight, and it's not even about how much difference there is in carbon emissions, or whether they know if that difference is significant and why. And then we also think there's a great opportunity to integrate the purchasing of carbon offsets in flight pricing, or at least to somehow have a one-stop shop. You just have to enter your credit card info once on one website, and you can get your offsets when you get your flight ticket. And then finally, we think this will be a really good strategy too, as biofuels become more prevalent, and airlines are going to want to really publicize that they're using sustainable fuels. If we could have, you could imagine an interface that has badges for biofuels on the flights that are powered by biofuels. In the same way, we would expect that to influence consumer behavior too, and help promote renewable jet fuels. And we're hoping also that all these things could have an industry-wide impact as well. If enough institutions or flight search companies were using them, the airlines would probably be motivated to prioritize their emissions and getting biofuels more so than they are now. So all these things we think are related. Our strategy is part of the puzzle, and all these other things are important as well. And I would like to acknowledge my partner in this research, Professor Nina Aminta of our computer science department. This was her brainchild from the get-go, and we worked together on this all along, and we've had tons of great talented students involved from computer science, design, and statistics departments, and we've enjoyed funding from the National Center for Sustainable Transportation.